So the voltage across the battery or whatever segment I'm looking at is equal to my current times the length of the wire divided by sigma A. This is still not the traditional form that you tend to see this equation. They decided to take it one step further. Sigma is conductivity. And the reciprocal, symbolized by the letter rho, because we don't use that enough, is known as resistivity. And if you find a table of conductivity and resistivity, you can just pull out a calculator, type in the conductivity, take the reciprocal, and you get the resistivity value. So my equation over here is that the potential difference across whatever I'm looking at is equal to I times rho L over A. And this is known as resistance. Cleverly symbolized by the letter capital R. And so now our formula now becomes delta V is equal to IR. I'm going to even circle that one because this is a good one to know. This is known as Ohm's law. Something else to keep in mind. Think about the first day. We wrote down Coulomb's, the force between two charges. Basically Coulomb's law. There's a direct path between that and this. This is just Coulomb's law fancy. The only difference between it is definitions in math. So Coulomb's law, just at a different level. Because Coulomb dealt with charges, this is dealing with flowing charges. So to date, we still have only one physics equation, Coulomb's law. The rest of it is just definitions in math. We don't get to the second physics equation until we get into the stuff for the test 2 or 3, whatever you want to call it. Questions to hear?
Question. So that R is just equal to what's inside the parentheses, the rho L over A, or to the whole equation?
Rho L over A.
Okay.
Yeah, somewhere I can distinguish that. Resistance is that part right there.
How does it relate to Coulomb's law again?
Remember that we defined potential based upon the potential energy. Potential energy is based upon the force, which was Coulomb's law. Current, we just defined it as charge over time. So that's a definition. Resistance, we based upon this, which is geometry, the L and the A, and then rho is material specific value, which I've erased now. So rho dependent upon the charge of an electron. I guess you could call it. It's not a physics equation though. That's a experimental measurement. So this is based upon experimental measurements, geometry, definition of current, and that goes back to force, Coulomb's law. So the lab that you're going to do on Thursday is the resistivity lab, where you're going to measure resistance using the ohm meter or the multimeter.
You're doing a lab on Thursday. I thought we have a test.
Oh,
Next Thursday,
the
right?
Thursday after that.
Oh, we can push the test back.
We can do the lab this Thursday.
Yeah, I'm gonna be mad at that.
The test, you do the lab after you do the test, right?
Exactly, we wait a week first.
Man, I have been so screwed up for the past year about what day of the month it is and what day of the week it is. I was thinking about starting a movement, an anti-pandemic movement. I don't know if other people would be hip to that, but that's just a thought I was having.
Apparently people are not up for it.
I guess the cult of Cthulhu would be, is into pandemics, but other than that. So, if I have a resistor here, so think about that. So before I put in the symbol for a resistor, remember that the resistance itself depends upon the length. The longer the wire is, the more chance it has to run into things, the more resistance. So when you make a resistor, the classic kind of resistor, you just take a long bit of wire and you can make it as small as you want, but you basically wrap it up in as tight space as possible, and you basically have a resistor. Now, a much simpler resistor, and what you'll be using next week for the lab, is basically you have a wire board right here, and this is a very thin wire, and so this has measurable resistance, but generally not particularly practical. And so you take a whole lot of tiny wire and you bundle it up into what is called a resistor here. Now there are other forms of resistors, but this is the classic kind. Notice that it is color coded. Can you see the colors? All right. The colors are a way of looking at it and knowing immediately what the resistance is. So this is what's called a 4-band resistor. The first three tell you what the resistance is, or what, with plus or minus. The silver band tells you the tolerance, and this is, I believe, 10%. So it tells you what the resistance is, plus or minus 10%. And I think almost all of ours are silver band. Now, in terms of might be able to look at it right now and say, oh, here's the resistance, that's something that I always have to remind myself every time about what the color coding is. So I'm not worried about it at the moment. But because a resistor is just a whole bunch of wire sort of tightly bound, the symbol for the resistor sort of represents that. That's the symbol for a resistor. So if I have a 12-volt battery here and I have current flowing through that is 3 amperes, then I can measure the resistance. I'm going to go through it the long way. Kirchhoff's rules. I start here, I go across the battery, so I gain 12 volts. I keep going, I go across my resistor here, so I'm going to lose some voltage across the resistor, and then I get back to where I started, and that's equal to 0. Because I'm going from the high side to the low side of the resistor, I lose potential. That's why I have a minus sign there. I know from Ohm's law that 12, this delta VR, is just equal to the current times the resistance. In other words, 12 is equal to IR, which is 3 amperes. I guess that's 12 volts. 3 amperes times the resistance. And so my resistance is 12 volts over 3 amperes. Which is what?
I didn't know if you were gonna go to the cross-sectional area or not.
No, not worried about the cross-sectional area at the moment. So 4, based upon this right here, volts per ampere, which was too much for them to write. They can handle Newton meter squared per coulomb, but they can't handle this. 4 ohms. This is the ohm. That is the SI unit of resistance. And I'm sure I've done it many times. There is an inverse ohm, which in one symbol is basically just the upside down, capital Omega, and that is the mho.
Really?
Yeah, it is a legitimate Scrabble word.
Do they do that on purpose? Or?
I've never actually, yeah, I mean, the fact that it's ohm backwards was on purpose. I've never actually seen this used, I just know it's a legitimate unit.
Is it American or is it international?
It'd be international.
Did they have a Larry and Curly there too?
They don't. Or Lahiri and Shirley. I think that they need to though. If they can do snap crackle and pop, surely they can do Lahiri, Maho, and the Hurley.
Or at least come up with a schmo.
Yeah,
Do the Joe equation and the schmo equation.
this is your chance. Become physicists. Get this stuff in. I can take this one step further. And let's just say that this is copper. Um, 0.0001 meter diameter. How long is the wire inside the resistor? Well, I know what the resistance is now. I know that the resistance is equal to rho L over A. So the resistivity of copper I have written down in here. 1.68 times 10 to the negative 8. So resistivity of copper. Now there are other values depending upon which source, 1.68 times 10 to the negative 8. That would be ohm meters. If I know the diameter, I can find the area here. I am assuming that the wire that they're using here is basically a cylinder. So my area is 1/4 pi d squared, or 1/2 pi r squared, or sorry, pi r squared if you want to divide by 2 to begin with. So this becomes 1/4 times pi times, it's 1 times 10 to the negative 8 once I square it, which is roughly 7.6 times 10 to the negative 9. Someone will correct me in a moment. And that would be square meters. So what is the area?
It's 7.85.
85. So the length of my wire would be AR over rho. So my area of 7.85 times 10 to the negative 9th square meters. My resistance was 4 ohms, and my resistivity is 1.68 times 10 to the negative 8th. All of these are in SI units.
I'm still caught at the area. area would only be pi r squared, right?
Right.
So that would be,
I gave you the diameter.
oh,
So did the,
yeah, I see. Yeah. Squared is 4, yeah. Didn't see diameter.
it all depends on what point you want to divide by 2. So what do we end up with this, the length?
I got 1.87.
Meters.
Yeah, meters.
So about my height. A 4-ohm resistor is not much. Now, in the resistivity lab, you'll also be using, so one part you're using the wire board over there, and another part you're using the resistance coils. Now, in terms of diameter here, you could go through and measure the, count out a certain number of coils, measure that distance, divide by the number of coils. Or, in this particular case, this is 10 meters right here, of number 22 B and S copper. B and S is a standard. So number 22 tells you basically the thickness. Then we have number 28 here, which is even thinner. And so it tells you the number on there. And in the lab, diameter of number 22 copper is 0.64 millimeters is the diameter. So my 0.1 millimeters is thinner than this stuff right here. See, number 28 copper, this is half the diameter. So this is 3 times thicker than my example here. But you would just look it up. The actual measuring of wire, there is a lab we do near the end where you actually will find the diameter of the wire. It's a fun one. You'll find the diameter of that wire. Can you even see the differentiation? Here's the closest. Yeah. Yeah. That's a fun one. But why spoil that adventure too soon? Something to look forward to. For those of you with really bad eyesight, you probably aren't the one who should be counting. Actually, I did come up with a method that works a whole lot easier, is I put it on a photocopier and then kept blowing it up and then counting that way. That way I could make marks. Yeah, that would work too.
We'll just
As
bring
long
a
as you can make-
magnifying glass.
Yeah, that works a whole lot better than the earlier methods where you were just counting and hope you didn't lose count or forget where you started. Good times. Oh, I was thinking we were done at 8:20. And we go till 8:30. Officially. Questions at the moment?
Do we have dates for the master sets, the next master sets,
I probably should do that.
and the quizzes?
So the week after that is spring break, or the
There was a
I think
16.
it's like, yeah.
take a small intellectual break while we figure that comes
So
out.
when does spring break start?
It was like the 16th to the 18th or something.
Tuesday through Thursday.
Yeah.
Days do we get this?
Probably
What, that was
Probably
one or not?
this whole week before.
That's not what it is for, spring break's different, I think. say.
I worked on a project, when it was one of the DuPont projects, where they kept track of when things would go to production and so forth, and all the testing and so forth, with sticky notes on a calendar. Which,
Where?
when I was working with DuPont. And my boss had issues with that, felt that we're IT people, we should be able to do something more sophisticated.
I'm surprised at all like that. Did you guys get audited at all? Cause that's like a big no-no with audits, you know.
But was it a big no-no 20 years ago? But some classics never die. So this would be 3, 9, 3, 11, so it's the following week, that's spring break?
When is it again? March?
The spring break is, March 16th through March 18th.
I think it's free.
All right. How about the Thursday after the test, master set 27? Master set 28 the following Thursday?
What were we doing for the quiz for those chapters?
Yeah, I was just,
Because I know you had talked about combining them.
how about instead of doing the quiz on the 2nd and the quiz on the 9th, we'll just do both quizzes on the 9th? Just because you've just done the test here, I want a little bit more recovery time, but we could split it up into quiz on the 27th, quiz on the 28th if you want. Split it up or together?
So if we put it together, that means we have 4 questions?
Potentially.
That's all that.
There are times I've done 3 and times I've just done 1 for each chapter.
Flash quizzes will be together.
Yeah, flash quizzes will be together. Or we could do flash on 27, flash on 28, and then the homework quiz is on the 20.
27th or Monday.
I think it's better
Saturday,
if we had like.
Saturday.
Right.
What?
What? I was referring to chapter 27, not the 27th.
Oh.
All right. All right, we got some choices here. What do you want to do? No opinion, I can just make something up.
Can you repeat the choices?
All right, so choice 1, we do the flash and homework quiz for 27 on the 2nd, and then the 28th on the 9th. Or chapter 28 on the 9th. Or we could do the 2 flashes and the 2 homework quizzes on the 9th. Or potentially, I guess, flash 27 on the 2nd, and then flash 28 and 2 homework quizzes on the 9th.
See, I don't think we should split up the flash quizzes from the homework quizzes.
I think we should do it how we normally do it.
I think,
like
yeah,
consecutively.
I like the,
That helps a lot.
27th,
yeah, because that's a lot of content.
I'm hearing it Brownsville, at least the vocal ones, so.
Yeah, quiz 27, master set 27 on the same week, and then
Okay.
quiz 28 and master set 28 on the same week.
But if you still want us to have a good recovery from the test, you could just make the chapter 27 quiz really easy.
I will keep that in mind. All right, but recognize what's still happening here is that coming back from spring break, and the test will be shortly after the spring break. So, that is helpful for some and hurtful for others.
So
For
it's
me,
not-
I would have hated to have the test right after the spring break. It won't be the day you come back unless people want that.
It's like a study week.
And don't forget, there's classes on Monday and Friday for some of you. This would be 3/16 plus 23rd. 3/25th.
Is this semester shortened?
It's 15 weeks.
Is that how it regularly is?
Yeah.
Well, that's, 2 years ago, year and a half ago, at some point they decided to,
Feels really.
That feels really short, right?
Yeah.
Dr. Welch decided that it should be a 15-week semester instead of a 16-week.
Hmm.
I was not part of that discussion, I don't know why. And now there's a move to make all the classes 7.5 weeks.
Oh, no.
Wait, what?
Wait, what?
They're just
Really?
being.
Yep.
That would-
So
that
if you're in
was-
Forsyth Tech long enough, you'll be seeing that the movement is for all classes to be 7.5 weeks. You'll be taking, so instead of taking 4 classes for the semester, you'll be taking 2 classes for the A section, and then
Oh.
2 classes for the next one. So you'll still get 4 this semester, but
They're just like throwing content down your throat, hoping you can actually learn it.
They save money on
So
professors.
is it like kind of like a corridor system?
like a what?
A
Like a
corridor
portal
system?
It is sort of looking like that's where they're heading, which they've done.
Why's
I think they were on the
that?
quarterly system.
Yeah, that's
before I got
ugly.
here. There have been some studies to show that students perform better in the shortened class, in the shortened time. It's more concentrated study, and the studies I read dealt with math and English. And that the carryover to the next class lasted better. I have not seen any studies for physics or actually any of the sciences.
So
You
will the
would,
class
you would
be
have to
longer?
break up your,
Yeah, you'd be meeting twice as long, sorry, more often.
I was about to say.
you would have to break up
Except 6
kinematics.
hours.
Pardon?
You would have to break up your kinematics and, I can't think. Projectile motion and whatever, you know.
No, it's, instead of, because 251 meets 6 hours a week-ish, and then it'll be 12 hours a week.
Oh, it would be.
So basically, instead of like 2 days a week, it'd be
Oh,
4
wow.
days a week.
Is
So
that?
you'd be
Yeah.
meeting
Oh,
twice a week.
so I see what they're doing, they're just like giving more class time throughout the week.
Yeah, that's
Oh.
what I've
But
been
what
led
about
to
those
believe.
people who have like work and stuff?
Yeah.
That is a darn good question. It's above my pay grade. Not for me to question why, just for me to do and die. All right, so if we're starting out, quiz 29 here, master set 29 there, and then is that April Fool's Day?
Let's see, yeah, April Fools.
Oh dang. Are you gonna make like
April Fools,
a
there is
story
no
for the
God.
test?
Wait, what?
Are you gonna make our test a score, a story?
Yeah,
Like the
it's
map?
gonna be like a really long, complicated question, and then on the back it's April Fools, just put 1 here and you pass.
I will keep that in mind. I'm not betting on that one, but.
Or maybe you'll just make it into a really complicated problem, and you have to like spell it out with the answer, like. Have
Interpretive
some kind
dance,
of
I was
coding-
thinking.
Yeah, have some kind of coding system with the answers that just spells out April Fools.
No, it's just if you read the directions, it says, turn it in.
I've actually never done one of those tests. The first time I was given one of those, read all questions before, I had already seen my dad taught, I think it was a Bible class he was teaching, where he did something like that. So I had seen it as a kid, and so when I saw this, read everything carefully, I thought, oh, one of those.
So, test will cover chapters 27 through 29?
Yes.
Also, if, if we have an impediment for that day, can we work with you to take the test
Yep.
on another day?
Yep. You're already making plans in advance
I
of being
have
fast on
plans
that
for
day?
that day, actually.
Oh.
I'll be traveling.
It's like, I actually
Yeah,
have
because
plans
it's,
on every test day.
Good
I
for
don't
you.
have plans on every taste day, just this one.
I assume that's gonna be an individual conversation we would have, Austin,
Yes.
if you have plans to travel every day. Or plans every day. I assume most of your plans involve studying physics. So.
Oh, definitely. I'll do my
Dream come
best.
true. Actually, it was really nice thing about grad school is the fact that you do get to concentrate on one thing. I can't say my thesis defense or dissertation defense were much fun, but, you know, the time in between those, was actually really nice. See if there's something else that I wanted to make sure I hit for that chapter. Oh, yeah. All right, any other questions before we spend 20 minutes talking about equivalent resistance?
The inverse.
Is that similar to?
Pardon?
Is this the inverse of equivalence capacitance?
Yeah, pretty much. I'm gonna justify it though.
Is this still chapter,
That's what I was going.
still chapter 28?
Still chapter 28. So I've got a really long wire here of length L. I know that the resistance of this wire is rho L over A. No significance between uppercase L and lowercase l yet. There's something in once we get to magnetism where we'll have to, I need to be careful about that because capital L means something special later on. If I break this wire up, treat it as two wires, so this is length L1 and this is length L2, then my resistance is just rho times L1 plus L2 over A. I am assuming that it's a constant area. And I can distribute here, so this is rho L1 over A plus rho L2 over A. So this first one just could be considered the resistance of part 1 plus the resistance of part 2. So if I wrote this out in symbolic notation, if this is my resistor 1 here, I could just write it as that, as resistor 1, and then resistor 2. In essence, for resistors in series, because any current flowing across one has to flow across the other one, there's no junction in between. So for resistors in series, the equivalent resistance is just the sum of however many I've got. R1 plus R2 plus R3 plus ad infinitum.
Okay, so is it kind of like the opposite